Welcome back to Chapter 2. Section 2-2 is on the properties of water. And as we've talked about in a previous chapter when we talked about the water cycle, 3/4 of the Earth's surface is covered by water. And the majority of that water is, of course, salt water. Water is the single most abundant compound in most living things. And actually, we are approximately 78% of our 100% body is comprised of just water. So what does a water molecule look like? Well, water molecule, the chemical formula for water is, of course, H2O. That means that there are 2 hydrogen and 1 oxygen atom that are bonded together by a covalent bond. So, the water molecule itself is neutral, but it has what's called polarity, which means that one end of the water molecule has a negative charge and one end of the water molecule has a positive charge. So a molecule in which the charges are unevenly distributed is called a polar molecule. And this is similar to like a magnet, where on one end of the magnet you have a positive charge and the other end of a magnet you have a negative charge. And there it is. The molecule is like a magnet with poles. Wow, imagine that. Okay. Polar molecules such as water can attract each other, and this is what keeps it so fluid and together, is because of this specific attraction. And what the attraction is forming or causing are called hydrogen bonds. The charges on the polar molecule are always written in parentheses because they're not a true bond. It's more like they are attracted towards each other. So it's not a true bond, for example, in like sodium chloride. So if you look here, this right here and this right here would be a hydrogen bond. So where the positive end is attracted to the negative end of another water molecule, that would be a hydrogen bond. Where this particular positive end is attracted to this negative end, that is a hydrogen bond. So once again, the attraction between the hydrogen atom on one water molecule and the oxygen atom on another water molecule would be an example of a hydrogen bond. And there are 2 properties that go along with water. They would be cohesion and adhesion. Cohesion is an attraction between molecules of the same substance. So cohesive or cohesion is of the same substance. Water is extremely cohesive because its ability to form multiple hydrogen bonds. So if we drew a lot of those water molecules, their ability to stick together, that would be an example of cohesion. So something that you might be able to relate to would be water beating up on a particular surface. Water is drawn together, and that's why it forms those little beads. The other one is adhesion. And adhesion is an attraction between molecules of a different substance. So an example of adhesion would be when we talk about looking at things in a graduated cylinder and we're trying to read the meniscus. So the surface of water in a graduated cylinder, and if you look at the graduated cylinder here, you can see that it dips ever so slightly. That's because on this particular side of the graduated cylinder, the water is more attracted to the glass than it is to itself, which means it pulls the water going upwards in this direction. And that's why we have this dip. That's why when you're taught to read things in a graduated cylinder, you're told to read at this particular line, not up where you see it up here on this particular line. Now, in this test tube right here, or in this cylinder, this is mercury. And mercury does not have the adhesion property that water does. So you can see if we were to read the level of mercury in this particular tube, you would just read it straight across. All right, solutions and suspensions. These are a review from physical science. A mixture is a material composed of two or more elements or compounds that are physically mixed together but not chemically combined. And a perfect example of a mixture would be the candy bowl that sits on the front lab bench. That's a mixture of different types of candies that you are able to separate, but yet again, if you put them all together, they are lots of different things together. So other examples of a mixture is going to be salt and pepper stirred together. You can physically see the difference between the salt and the pepper granules. Sugar and sand. And the Earth's atmosphere is also a mixture, but it's a mixture of different gases. Solutions, and the most popular one is, of course, when we put table salt or possibly sugar into water and mix it around. Everything kind of disperses, so the solid is going to disperse in the liquid and the bonds are going to be broken, and then the salt or possibly the sugar are going to dissolve. So the ions gradually become dispersed in the water, forming what's called a solution. And in a solution, the particles are evenly distributed throughout, and that's the key to a solution, evenly distributed throughout. If there is too much of the stuff that you're mixing in, which is called the solute, that you're trying to dissolve into the solvent, then it becomes too saturated. You may have heard that term before. So, for example, in a salt water solution, table salt is the solute, or it's the substance that is dissolved. That is what a solute is, the substance that is dissolved. The solvent is the substance in which the solute is dissolved into. So the solvent is the substance in which the solute is dissolved into. And water is the greatest solvent on earth because it can dissolve just about anything. So once again, water is the greatest solvent on earth. Next, we come along with what's called a suspension. And if you think about what the word suspension means, it means going between two places, or being suspended, or being lifted over something. So some materials do not dissolve when placed in water, but separate into pieces so small that they do not settle out. And this is called a suspension. So once again, a suspension is a mixture of water and a non-dissolved material. Some common suspensions are blood. Your blood can actually be separated, and when you go to, or people go to give or donate plasma, what they're doing is they're removing, that machine that the people are hooked up to, are removing the plasma from the person's blood and putting the other parts back along with some saline solution to replace the plasma that is being taken out. So really, they're filtering the plasma out of your blood because your blood can separate into different layers. Another example is cornstarch and water. Another example would be flour and water. Or orange juice. Orange juice is a suspension. That's why you have to, it settles after a while, or even lemonade. That would be something that it settles for a while, you shake it up, and then all the particles will disperse. A colloid is between a solution and a suspension. So examples of colloids would be milk, fog, and jello. So if you think about jello sitting in the refrigerator and you leave it there for a long period of time, there's a little layer of water that might be on the top, especially those jello things that you lift the tops off of. So that would be a colloid where just a little bit is going to lift out. Or milk, you can think of sour milk. That would be another example. On to acids, bases, and pH. And I know that this is something that possibly you talk about very briefly in physical science. The pH scale is a measurement device used to indicate the concentration of H plus ions in solution. H plus is sometimes referred to as hydrogen or hydronium. So H plus is sometimes referred to as hydrogen or hydronium ions. That's important to remember because some of the worksheets are going to say hydrogen and some might say hydronium. The pH scale ranges from 0 to 14. And a pH of 7, once again, is neutral. That means it has the same concentration of H plus, which is hydrogen, and OH minus. OH minus is hydroxide. So H plus is hydrogen, and OH minus is hydroxide. When these are equal, that particular solution is said to have a neutral solution and a pH of 7. Anything below 7, that is acidic. Anything above a pH of 7, the solutions are said to be basic. And here would be an example of a pH scale. And if you're looking at the pH scale, neutral right here, that would be pure water and milk. Once again, you go down the scale. Number 1 would be a very strong acid. And if we go this way on the pH scale, 14 is a very strong base. Right here, you're going to have a weak base. And right here, you're going to have a weak acid. One thing to also remember, our acids are usually referred to with the color red. Base is going to be the color blue. So you'll look at some of these things on here that talk about different acids and bases, and you'll have a copy of this in your textbook along with your note packet. So an acid is any compound that forms hydrogen ions in solution. They have more hydrogen ions than hydroxide ions in solution. So more hydrogen than hydroxide ions in solution. Strong acids tend to have pH values that range from 1 to 3. On our scale, we wrote that 1 was a very strong acid. Hydrochloric acid produced by the stomach to help digest food is an extremely strong acid. A base is a compound that produces hydroxide ions in solution. Once again, a base has the hydroxide or OH minus ions in solution. And strong bases such as lye is soap. So lye is soap. Tend to have pH values ranging from 11 to 14. Last but not least are buffers. And buffers are something in your body that keeps everything relatively neutral. So the pH of the fluids within most cells in the human body must be kept between 6.5 and 7.5. So pH is very important for maintaining homeostasis. And you'll remember this word from the very beginning of the school year when we talked about equilibrium or homeostasis. Your temperature likes to be at 98.6. Your blood pressure needs to be at 120/80. So you need to make sure that everything stays the same. That's including the inside of your body. Buffers are weak acids or bases that can react with strong acids or bases to prevent sharp, sudden changes in pH. So your key example right here is going to be your Pepto-Bismols or your milk of magnesias or your things that you take when you have an upset stomach. Because there's too much acid in there, it's going to relax that and try to neutralize the acid that's in your stomach. So that is what a buffer does. And that concludes section 2-2